Now we can move on to our simulation association of the DS1104 to see how it can be visualized and applied via our computer. As you can see here, this is our original surge control optimization of the induction motor. It contains firstly the optimization algorithms here, and a vector control, general vector control block, but also a DQ module of the induction motor to convert this to become a interface that can be applied to the DS1104 processor. Firstly, we have to delete the DQ module of the induction motor. Instead, we have to generate the general three-phase voltage and convert it into their corresponding duty cycles. The input and output communication is achieved by some specific Simulink module. As you can see here, this module is used to generate the PWM signal of the left PWM generator, which is our induction motor. On the other hand, since we will test our module under different torque conditions, a constant torque control of the DC motor is also applied here. And two-phase PWM signal will be applied to the DC generator. We will test our surge controller algorithms. Firstly, under the light speed condition, we will gradually increase the speed to 0.2 per unit, and also the magnetizing current will be applied in front of the speed command is applied. Firstly, it will work under the rated magnetizing current scale, and then the surge controller will be triggered by the speed and torque condition to say if it is working under the steady state. Now we can upload our Simulink module into our DSP control system. Okay, this is a combated software named as Control Desk. Here you can change the values if you want and visualize all the parameters being tested in the Simulink module. Okay, so we can reload the application and start the Simulink simulation and make it work in the animation mode and check the reset button. We can now wait the induction motor being activated. As you can see, the speed will gradually be increased, and the signal will be stored into the capture setting windows. As you can see, after the transient stage, the current will be reduced to find the optimal working condition. On the other hand, the input power is also reduced. When it is become a little bit stable, as you can see, the torque current level is also be a little bit increased to maintain the torque unchanged. Okay, so we can now wait the induction motor to stop, and then we can finish our real-time simulation until the signal jump to 0. Okay, first stop the animation and stop the whole simulation. Okay, we can make a short examination on the plot we obtained. As you can see here, after the transient stage, the surge control is triggered, and the power is actually be reduced compared with the current level at the rated scale. We can also compare the real-time simulation result of the loss module control and the surge controller. As you can see, the search controller is represented by the blue curves. Due to the poor parameter deviation, the module of our loss module control may not be accurate. So it will not convergent at the minimum power point. However, the search control does not depend on the accuracy of the module. It can achieve better convergence. However, the searching step is also long, and more power will be lost in the transient stage. Thank you.